Give yourself a hand for coming out tonight. Yeah, very good. Thank you all for coming. For those that don't know, I'm Joe Kessler. I'm president of the Friends. And this is one of the Friends, let's just call it pop-up events. We're sorry that it's a little bit cramped quarters, but meeting space is kind of limited these days, so we're going to have to make do. So please make yourself as comfortable as possible. And anyway, I'd like to thank you all for coming out. Very important subject, the state of the reefs post-hurricanes. And very grateful to two of our local experts, Jeff Miller, who's with the Park Service, and the Marine Monitoring and Evaluation Unit, and Dr. Caroline Rogers, with USGS. Two of the most knowledgeable, if not the most knowledgeable people, at least in our small community, about what's going on here under the water. And they both, over the last many months since the storm, have been out and about studying, investigating, analyzing, evaluating the state of the reefs. So that's what we're going to do tonight. I will give you a little advance notice. On the 16th, on April 16th, Eleanor's here. Eleanor will do a talk on what's above the surface. You know, the state of the terrestrial resources post-hurricane. So put it on your calendars, and I hope to see you here. And maybe April 16th, same time, 5:30, same place. We'll try to get a few more chairs, but not a whole lot more room for chairs. We'll see what we can do. So without further ado, I'd like to introduce Jeff Miller. Take it away, Jeff.
Here we go. Thank you all very much for coming. I really appreciate it. Thanks for rearranging your schedules to be able to be here for this. We'll take questions at the end. If there's something just really pressing you got to say, let us know, but we'll answer the questions as best we can at the end of the program so we kind of keep the flow going and keep it moving. But thanks to the Friends, thanks to the National Park for having us here and providing the space for us. Wasn't sure who all was going to come, so I thought, okay, we better have just a little refresher over what we went through. This is a little video from a friend in Irma. Yeah, we were in the eyeball for a while, and that it was really an intense experience. So I don't think anybody really wants to go into that any much further. We saw what happened on the land, and we've seen a little bit of recovery. Things on the land, like I said, Eleanor is going to go into this in much more detail, tend to respond a whole lot faster than it does in the water. So the question is, what really happens on water after a hurricane? Before I go into that, let's talk about reefs and really what reefs are and what they mean to us. I mean, so what if the reefs get torn apart? What's the big deal? So, besides being a source of natural beauty, reefs provide structure. They build structure. They build habitat. That habitat and that structure then becomes the source of being for an incredible diversity of other organisms associated with those reefs. So they are a cascade of an effect that just builds this really complex ecosystem. It is a place that has some of the most incredible, the highest biodiversity on the planet. And from that biodiversity, we get all sorts of materials, chemicals, medicines. We get food. And the problem is when that starts to break down and go away, we don't know what we've lost because it's gone. So that can be a big problem. We get shoreline protection from that structure. We thought the erosion at Maho was bad, but imagine what happens at that reef further offshore by where we call it Wind Spirit Reef. If that wasn't there, that wave energy on the shoreline would have been even more intense. We get economic benefits from reefs in the billions of dollars. That's not millions, that's billions. And that's from a publication by Reefs at Risk, which is a really excellent document to take a look at. And quite frankly, it's the job of the national park to take care of these systems. The legislation that created the national parks in 1916 states that the mandate for the National Park Service is to conserve the scenery and the natural and historic objects and the wildlife therein, and to provide for the enjoyment of the same in such a manner and by such a means as will leave them unimpaired for the enjoyment of future generations. That's a tremendously lofty goal, and it's something that I think is really worth striving for. So what happens underwater during a hurricane? This is the same piece of coral from September 2016 to November 2017. I can't imagine how many hundreds of pounds this coral weighs. It's located about 45 feet. It won't survive this. We don't even know how fast pillar coral grows, so we don't really know how old this coral is. But the damage that you see underwater is largely a function of where you're looking. I've seen Facebook posts and people say, well, it was just completely destroyed. And I've seen others say, well, it wasn't bad and it's already starting to come back. And the truth is it's kind of both of those. So let's talk about what you see when you look at specific places. A lot of the coral around the island grows in very low profiles, especially up against the keys, up against the shoreline. They're relatively low profile. They're reefs that are growing on rocks. They're encrusting reefs. They grow in about 20 feet or less. Think of these as the places that you go when you go snorkeling. These are places like off Trunk Key, off Cinnamon Key, off Whistling Key. They're near shore Groat Pond and Salt Pond and Kittle Bay. So those are the places where you find these relatively low profile reefs, and they did pretty okay. They they exist well in high wave energy environments, and that's certainly what we had with 2 Category 5 hurricanes. Another type of reef is a higher profile reef. Reefs that grow up and off the ground, reefs that are growing on top of themselves. These are more emergent type of reefs. They grow up in the water column. They're deeper than 20 feet. They're usually the things that you associate with people seeing when they go snorkeling, when they go diving. So that kind of parses these two different. These are vulnerable in storm events and wave energy to being toppled over. And that's what we commonly see. They're the things adjacent to the keys on the North Shore, Leinster Bay, and some of the study sites we'll talk about as we go on. That's where you find these higher profile reefs. Now, just because part of a reef is knocked over, doesn't mean it's the end of things. So this picture in the middle, that's the small star coral in that columnar form, the column form. And this picture shows one that was knocked completely upside down, and it now has become habitat for other corals to grow on top of it. So just because it's upside down doesn't mean the end of the world. It certainly changed the world for a little while, and it was a net loss, but there's a gain that slowly comes back if that coral just doesn't continue to roll around. It has to stabilize itself in that new position. So some toppled reefs do become future habitats. So let's take a look at these different places that have these different style reefs, and that may help us dialogue into what happened in water. Those relatively low profile reefs, those encrusting reefs, generally found along the North Shore at those popular snorkeling locations, right? And this is all very qualitative. I mean, I went in and I looked around at all these places, didn't take any measurements, but my general observations of this kind of stuff is that there's moderate damage. Certainly there are toppled and displaced corals, no doubt about that. You see sea fans laying on their side, no doubt about that. You see large trees and debris bumped up against the corals, no doubt about that. But you also see many corals still attached to the bottom and still in growth position. And that's a very positive thing. Okay, it could have been a whole lot worse. When I went snorkeling at Hawk's Nest and saw this kind of rubble around there, I was really discouraged, but then I went out towards the edge and saw that there was still coral upright and in growth. And even after the swell that happened at the end of February, which caused a tremendous amount of energy on those shallow water reefs, it still is in that growth position. So I know it's hard to go out there and see your favorite things laying on their side. Maybe they'll stabilize and new stuff will grow on it. But we've got to look at the things that did survive, because with the amount of energy that was expended upon those shallow water environments, it could have been a whole lot worse. Let's take a look at the higher profile reefs. The reefs growing upon themselves, the deeper reefs. And I'm going to focus specifically on our study sites. We have 4 of them that I'll talk about tonight. All Over Reef, Medebeck, Yawsey, and Tektite Reef on the South Shore. These places, the shallow water portion of those that were between 20 and 30 feet, they got messed up a little bit. And these pictures are from those reefs. This small star coral is actually one of the corals listed on the Endangered Species Act as threatened. So not only is it knocked over, it's one that we're giving extra special protection. So this is difficult to see. Another example of this here is at Tektite. This is a very shallow water transect. So this is the same line on the bottom. This is one of our study points. I know it's the same place because that's exactly the same coral. We have that pin in the water. But what's interesting here is where is that stuff on the left? On the picture on the right. It's just completely gone. So this again, high energy shallow water environment where those corals that have a little bit of a higher profile took the brunt of the energy on the wave action. We also saw that after the storm, the water quality wasn't what we're used to. Corals like very low amount, coral reefs like low amount of nutrients. And somehow we had a lot of nutrients in the water. Now, whether that was from shoreside runoff, whether it was from deep water upwelling, whether it was from this organic material that had washed off the land and was now decaying in the water, I don't really know the answer to that, but the combination of all those nutrients made the plants grow like crazy. And what we saw was abundant, fleshy algae that's overgrowing some of the hard corals and the soft corals. And that's not so good. We'd like that to go away. Sometimes just age and wave action will take care of that, but that's kind of troubling to see. But this is the effect of these storms. None of this is uncommon. This is stuff that we typically see after these wave events, these storm events. So when we're looking at the reefs, these 4 study sites that we've been going to for decades, and I've got to put this in the context of coral cover. What's coral cover? Easiest way to describe coral cover is with this picture. I mean, I think you can tell there's heads that are covered with different amount of hair. So what we do is, I'm not going to identify this. We look down onto the reefs and use scientific methods to actually identify and quantify, to measure and count how much of the bottom is covered with what kind of stuff. So that's what we talk about when we talk about percent cover. So I'm going to talk about the percent coral cover. And at Haulover, this is a figure from 2003 through 2018. We just were there in January. We see the big die-off that occurred after the disease and the bleaching in 2005 and 2007. But we didn't really see a change between 2017 and 2018 from the hurricane. Same story at Mennebec. No real change between 2017 and 2018. Same story at Tektite. Even though we had that destruction in the shallow water, there's enough deep water within the study site, and there wasn't the destruction there, so the coral cover stayed the same. But unfortunately at Yawzi, we did see a 31% decline in coral cover, which is what you're seeing right in that bar there. Yawzi tells kind of an interesting story. We had this decline between, oh, don't look at that. We had that decline between 2005 and 2007. But notice that Yawzi had recovered, right? It had actually almost got up to where it was pre-2005. Unfortunately, this storm set it back about a decade. And that's kind of hard to take. Here's kind of an interesting case study, right? So what I've talked about is high-profile reefs, low-profile reefs, and a depth contour about 20-25 feet. And Leinster Bay is a place that kind of tells the whole story. I'm going to focus in on this 3-buoy area in Leinster Bay, right in here, kind of up near the shoreline. It's a relatively shallow, and then it slopes off deep. That's where you can see that dark color come in here. That's the depth gradient. So the shallow, even though it was relatively high profile, it got hit and pummeled pretty bad. I mean, in places in that area, it looks like somebody actually took their arm and kind of scraped it off the bottom. But when you go a little deeper, and I apologize, my picture didn't turn out. When you go deeper in that 3-buoy area, down to that 30 and 40 foot depth, it looks pretty okay. I mean, again, yeah, it's a little toppled, but it's mostly okay there. Shallow water took the brunt of most of that work. Now you go just a quarter mile away to Water Lemon Key. Now you've got kind of a shallow, relatively low profile area. You can have some higher profile stuff. It did get a few corals toppled. This guy is interesting. this coral actually rolled around and ended up right side up, which is kind of cool. But you can see how it rolling around kind of chewed a lot of the live coral cover away. Hopefully that will begin to resheet itself. But mostly, water lemon key turned out all right. I mean, it looks, for the most part, like it did prior to the storm, which is really pretty amazing in that it's just a quarter-mile away. We still don't know why that happens. I mean, why does some places just get pummeled and others are okay? So that's kind of a cool story. So just a contrast between, you know, the more encrusting type and the more high-profile types. So what happens what happens underwater during a hurricane? The tough story, the hard story, is that we lose structure. That structure is the key to so many things. It's, gosh, and this is really a tough analogy, it's like an apartment building. It's like a house. It's like where we live. And when your house blows down, you don't have a place to live. So when we lose the structure on the reef, those other reef organisms go someplace else. And the other thing that we haven't got this nailed down yet, but we think we're seeing is that when the reef is contiguous, when there's good reef structure, it provides more of a barrier and a stronger barrier to the wave energy and the wave action. But when there's cracks and breaks in that structure, it begins to crumble and fall apart. So it's really important that the reefs stay well developed and well formed. What about the other stuff? What about sea fans and sponges? Sea fans, one of our investigators has done some work on the south side. He estimates there's about a 20% decline in the octocorals. That's the sea fans, the sea whips, the sea plumes. So he's estimating about a 20% decline. Preliminary information, not quite ready for prime time yet. Our data from our study sites show an almost 60% decline in sponges. That's pretty troubling. I mean, sponges really took a beat. You can see a lot of them up on the shoreline when you're walking along the beaches. Now, we don't know if they just got kind of torn off and will reform. That's yet to be seen, or if they're completely eliminated from the bottom. But we'll see what happens with that. What about the fish? I got to ask you to stay tuned for future coming attractions with the fish. Here's what we know about fish and storms. Got to throw another data slide up in here. This is from some collaborators. This shows that 1989 was Hurricane Hugo, 1995 was Hurricane Marilyn. These are the 5 most abundant families of fish, and after each of those storms, they took a dip, but then they bounced back up. Okay, so again, it's about the structure. When your home is destroyed, you go someplace else. So when the habitat is messed up, it either long-term or short-term affects the fish population, and depending upon how bad the habitat's messed up, depends upon how rapidly they come back and reinhabit the system. So we've got some more sampling to do on our fish surveys, and we'll have some information on that, but we just don't know about this answer for these storms yet. So let's talk about some good news. Okay, I think all of it's kind of good news. I think it could have been a whole lot worse. But the good news that we can see specifically, this is pillar coral. That tells an interesting story. This pillar coral was taken, I took this picture off of Cinnamon Key. It was affected by some disease, and it had some of the columns just torn off. So that's where you see those stumps. Now, if you go a little bit further down, a little bit deeper than this pillar coral colony, you find this pillar coral colony. I mean, these two are the same colony, but this guy here is absolutely fine. Didn't even have anything broken off of it. So 10 feet deeper, it did okay. Right in the same area. That's amazing. I mean, that close together, you get such different effects. Now if I go a little bit shallower, about 15 feet away and maybe 10 feet shallower, I run into this guy, which is kind of a pillar coral that was growing on the side of the rock, encrusting on the rock. And you can see most all of the columns are broken off this. Okay, so shallow water took the brunt of everything. But when we look close at these pillars, this is kind of cool. Because what you actually see when you look at those is it's growing back. Okay, that little 3/4 of an inch of growth is post-storm coral growth. that is covering over that broken column. Okay, and I'm betting that this is new coral growth as well, that little nub right there. But that's the scale of growth that we're talking about. I mean, we're talking less than an inch in 6 months. Okay, so I go back to those Facebook pages. We're not seeing recovery really fast. But what this tells us is that the conditions are still right for coral growth to occur. And that's really good. This happens in elkhorn coral, okay, out at Hawk's Nest. This was photo taken in October. You can see the blunt ends. And then this picture was taken just the other day. And you can see here that all this is new growth. It's actually covering up those broken ends. And now that will extend out in the water column and form new branches. This is the good news, okay? We can't give up. Because if we give up, then we've lost. Okay? But if we continue to do things to help protect reefs, they've got a chance. And that's why it's really great to see everybody here. Okay, let me throw just a little bit more science in you because, yes, we are in hot water. We have data loggers that are out in the water. They record water temperature every 2 hours. And we've been doing this since 1988. And this is a track of our water temperatures, which means it gets hot, it gets cold, it gets hot, it gets cold. But what we also see in this picture is called a bleaching threshold, and that's that line where when the temperatures get above that line, you know that the corals are really stressed out. And they can respond to that stress by bleaching, by losing their zooxanthellae, the thing that gives them color, the thing that's giving them their energy, and that's a really stressful thing. We know that in the most recent decade, that water temperature has gone above that bleaching threshold more than it did in the first part of the decade of this 22, 24-year series. So this is troubling. I mean, these are the number of days above that bleaching threshold. Didn't occur very often. Now it occurs all the time. Except for last year, 2017, right? Didn't occur very much at all. We just had a few days over the bleaching threshold. And that's because our 2 storms came by, mixed up the water, cooled it off. So we're in a really rough place. I mean, you were talking between a rock and a hard place. We're between boiling hot water and hurricanes. I mean, I can't believe I'm going to say it, but I'm going to say it. We need a near miss every year to cool the water down so that we don't have bleaching and all the cascading effects that go along with that. But who the heck wants to have a near miss? Or certainly what we had last year. So this is a difficult situation to be in. Okay, those of you that see my presentations know I have to put this one in here. We look at reefs differently than most people. So I try and equate what happens on reef to other national parks. And this is what our reefs looked like prior to 2005. They looked really great. And then 2005, 2007 came along, and we had a lot of trouble and a lot of doubt. So since 2005, 2007, things have kind of pretty much stayed the same. Maybe a little bit of growth, except at that reef, Yalzi Reef. Now this is Yalzi Reef, okay? So you may not see it that way, but this is Yalzi. And it was really cool, right? It looked nice prior to 2005. And then, well, it got hammered a little bit, and it lost about 40% of its cover. But then it started to come back, and it was almost back to what it was before. And then, well, this happened, and now we're back to here. So that's the way a lot of people see reefs. I hope these pictures prior to this have showed you the way I see reefs and the way you can see them when you're out snorkeling. So here's the take-home messages. Every living piece of coral is more important than ever before. Okay? They survived the storm. Okay? Don't step on them. Know that when you're going in the water that you're stepping on sand. Okay? I mean, they're survivors. We're survivors. We don't need another earthquake. We don't need anything else, right? So let's not step on any corals. Don't drop anchors on them. You know, if you're talking to somebody in the water, hey, this is the most amazing thing I've ever seen, float on your back. Float on your back and talk to somebody so that your feet aren't anywhere near the reef. Then you turn over on your stomach and you look at the bottom, and that way you haven't affected the bottom. Know where the fish you eat comes from. Okay, healthy fish populations on the reef make for healthy coral reefs. These national parks are more important than ever before. Okay, in national parks, we try to reduce the human-induced effects upon the environment. We can't get rid of hurricanes. But what we can do is try and minimize the amount of stuff that we bring onto reefs so that once the hurricane is passed, the reefs can have the best chance they have to recover. And then those reefs become the source of reefs in the future generations. And then, I guess that's just what I said. These reefs, these corals, these fish are the source for the reefs, the corals, and the fish for the future generations. It's never going to be what it was prior to September. Okay, I'm sorry to say you're not going to see it like it was in August. But your kids and their kids have a chance if we take care of it. And that's our job. That's what we need to do. So, that's my big wrap up. I'm going to turn it over to Caroline here, and then we'll take questions at the end. Thank you.